Hi, this is Mr. V, and in this video we want to determine the net force acting on an object. So, in the past we've looked at how to draw a free body diagram, but back then we didn't know what the actual forces were. Now we do. So, in this example here we have a rocket, represented by a dot, and the thrusters are applying an upwards force of 1200 newtons. At the same time, gravity is acting on the rocket, causing it to accelerate downwards with a force of 800 newtons. What is the net force? Which one's going to win, our upwards force or our downwards force? I'm sure you can already see that we're going to have an upwards force here, but how strong is that upwards force, our net force, going to be? Well, we can figure it out by subtracting the two forces from each other because they're in opposite directions. So 1200 minus 800 is 400 newtons. So our net force is 400 newtons. We can then use that force to determine the acceleration acting on our rocket. Here's a similar problem. Bill and Jason are pushing a trolley. So again, I'll use a dot to represent my trolley. Bill is using a force of 20 newtons. Let's assume that Bill is pushing this way. There's 20 newtons. Jason is also pushing the trolley. So pushing the same direction, but he's pushing with a force of 30 newtons. So the first thing we want to do is figure out what the net force is. Now in this case, because both Bill and Jason are pushing the trolley at the same time in the same direction, our net force is going to end up being much longer than both of them. Here it's going to be the length of both of them added up. If I add up the forces 30 newtons and 20 newtons, that net force is going to be 50 newtons. It is that net force that is causing the acceleration. Now we also know our mass. We now know our force and our mass, so we can calculate the acceleration. Acceleration equals force divided by mass. Our force is 15 newtons. Our mass is 35 kilograms. And my calculator tells me that 50 divided by 35 is 1.4 meters per second squared. So the trolley is accelerating at 1.4 meters per second squared. And that is how we can determine the net force acting on an object and use the net force to perform calculations.